Hello learners, welcome to Physics Form 4. I am your teacher, Mr. Nderitu Felix from Kiamutugu Boys High School. Now, today I want us to look at thin lenses, a very interesting topic. One topic that is easily confused with a topic in Form 2 that involves curved mirrors. But we are going to do it in a very simple way so that we avoid such confusion later in the future. Now, we know or we have seen lenses. A lens is an object that is made of a transparent material. We know that material can be grouped into three categories: transparent, opaque, and translucent. Now, if the material is transparent enough, it makes what we call a lens. Lens can appear in very many formats. For example, lenses can be made of glass, plastic, or perspex. Those are just some examples of materials that are used to make glass, and I know that some of us maybe might be not familiar with plastics making lenses, but they are now the modern things. We find them in spectacles and they are clear, just the same way we have glass in window panes. We also have perspex. It's also another material that is used in making lenses. The other thing is about the uses of lenses, application. Lenses can be used in cameras. For example, now that we are recording ourselves, we are using a lens in this camera that you are using here, and you're also recording your photos maybe at home during the holidays using a camera, and it has a lens. We also have spectacles. Yeah, myself, I'm wearing spectacles to aid in my vision, and those spectacles are also made of lenses. Later, maybe we are going to be looking at what type of lenses am I wearing. Are they for somebody maybe who is not seeing far? We have a name for that, or not seeing near things. We also have a name for that, and we shall be looking at that later. And interestingly enough, you might be saying that the only people with lenses are those who have eyesight problems. But interestingly enough, even every human being and every animal with an eye has a lens, a natural lens inside the eye, which we shall be looking at also later. Now, the next thing, let us look at the principle that guides lenses. Why do lenses work? So the principle that they work under, this is also like saying the reason why lenses work is because of what we call refraction. Refraction of light. Some people like calling it the bending of light. So the ability of a lens to take light traveling in a straight line and bend it, maybe to converge or to diverge, is the principle under which these lenses are going to be working. Next, we look at types of lenses. We have two types of lenses. Two types of lenses. And these two types of lenses are grouped using this principle. How do they bend that light? Is it towards each other or is it apart from each other? So the first group of lenses is what we call the convex or converging lenses or lens. And we have so many types. They can appear in different shapes. And the first one is this one here. This one is called a convex meniscus. Convex meniscus. We also have another shape here. A plano convex. We also have a plano convex. We also have another one here. A biconvex lens. And finally, some books, they also call it equiconvex lenses. Now, in case you are doing an exam and we want to say that inside that practical lesson, we shall be having a lens. There is a symbol that is used to represent that in a practical, and this is the symbol. So when you see that symbol, this symbol represents that in that practical, you are going to be having a place where you use convex lenses. There's also something interesting about convex lenses, that if you correct a convex lens, there is a property that the edge or the tip, the upper side, is very thin. It's fairly thin compared to the center that is fairly thick. So maybe you're walking around and you have just collected a lens. Maybe somebody's watch had dropped a lens, and you want to know which type of a lens are you dealing with. It is good to learn that the convex lenses are designed in such a way, the edges, these corners, they are somehow thin as compared to the center part. Now, why are we calling them converging lenses? What is all this about converging? And as you know, converging is bringing together. The reason they are called converging lenses is because if you have some rays that are moving in a parallel line that way, then they come and hit. Let me take one of the examples, the biconcave. What happens, biconvex, pardon, what happens is that the rays are bent towards a central point, this one here, and that's where the word converging, meeting, comes from. Now, the next type of lens, which I want us to look at, the second type, apart from the convex, is called number 2. The second group of lenses, number 2, they are concave, also known as diverging lenses or lens. Now they are different, they can appear in different shapes. For example, we have one here. This is known as a concave meniscus. We also have another type, this one here, known as a plano concave lens. Next, we have this one. This is a biconcave lens, also known as equiconcave. In case you're in a practical and they want to show you that inside the practical, somewhere you're going to be required to use a concave, then this is the symbol, either or these two symbols. So these are the symbols that shall be used in a practical to show that somewhere in your working you require to use a lens. But how do you know that whether the type of lens you have is a concave just by looking at the shape? It has a property. Look at the edges this time round. The edges are thick, relatively thick as compared to the center, which is fairly thin. And that is one property. Just by holding an example of a concave, you notice that the center is very thin and the edges are very wide. Now, another thing we need to look at is, why are they called diverging lenses? Where is this word diverging coming from? The diverging part is because of how they do to the light. So assuming we have some parallel rays here, we have some parallel rays there moving. Once they hit, let me take an example of the biconcave. Once they hit here, they meet at the same, they don't meet, this is converging, they should diverge. So pardon, they should diverge outside, these spreading out. So this is where they get their name from, because that lens is able to spread out. Now next, I want to make a small clarification where so many students make a mistake as we wind up. In Form 2, there's what we call the converging mirror. And today we have also learned a lens can also converge. So let me wind up with this statement. A converging lens under this topic is a convex lens. But in Form 2, a converging mirror, a mirror that is able to converge right, is called a concave mirror. The opposite of this statement is true, that a diverging lens is called a concave lens. A diverging mirror in Form 2 is called a convex mirror. So that's a very interesting thing to learn, that it's not always that converging are always convex, sometimes it changes. I'll leave you with something. Why is this topic known as thin lenses? Why thin? Why not thick lenses? Let us meet next time, and thank you for attending this lesson.